any questions before we move on to and? All right, so when we're dealing with and, okay, we don't really have mutually exclusive and overlapping. It's called independent and dependent, meaning there's going to be events that don't affect each other and events that do affect each other. Okay, if we have something that is independent, okay, we take probability of the first thing times the probability of the second thing. If they are dependent, we take the probability of the first thing and then the probability of the second thing given the first. So basically, it sounds a little confusing. It'll make more sense once we practice it. But basically, you have to add in probability of A with the probability of B. Okay, and that we'll iron that out when we do an example. It'll make a lot more sense. Okay, so an example. If something is independent, an example would be flipping a coin and rolling a die. Neither one is going to be affected by the other result. But dependent would be drawing two cards without replacement. Okay, so if I draw a 10 of hearts, and if I draw a 10 of hearts and I don't put that back in, that affects my next draw. Because I know for sure there's going to be one card I cannot draw. So that would be an example of dependent. Okay, questions on those? Some of you are still raised, that's fine. We're going to answer some questions, and I think once we start doing some real life examples, you'll be like, oh, this isn't too bad. Okay, you just have to decide what's what to be able to pick things out. Okay, we good? Anybody still writing? Alright. So the way that we randomly choose a card from a standard deck of 52 playing cards, find the probability that you chose a queen or an ace. So the first thing you have to ask yourself, is this and or? What do you think? Or. Okay? Right here we see the word or. So it's going to be a union. Okay? Then, if it's a union, you have to decide, is there overlapping or no overlapping? Okay? Can we choose a queen ace? Is there a card in the deck that's a queen ace? No. Okay, there's a queen or an ace, but there's nothing that's overlapping there. So I'm going to go back to my chart here. Okay, if I am non-overlapping, then I'm going to use this right here. I'm going to add the probability of the first thing plus the probability of the second thing. So what's the probability of getting a queen in a standard 52 deck? How many queens are there? 4 queens. So it would be 4 out of 52. Plus, what is the probability of getting an ace? 4 out of 52. Okay, luckily those have the same denominator, so we can add them. So we'd have an 8 out of 52 probability. If we find the percentage, about 15.4%. So it's saying if you chose one card, okay, so it's queen or ace, You chose one card. Okay? Got 15.4% that it would be a queen or an ace. All right, find the probability that you chose a king or a club. Is this a union or an intersection? A union because of the word or. All right, is it overlapping or not overlapping? Overlapping, because you can have a king of clubs. That is a card that is in the deck. So, if we go back, okay, overlapping means that we're going to do the same thing we did last time. Probability of the first thing plus probability of the second minus the overlap part. Okay, and that'll make sense in just a second here. So, what's the probability of getting a king? 4 out of 52. What's the probability of having a club? How many clubs are in a deck? Okay, how many suits are there? 4 suits. So you do 52 divided by 4, which is 13. So 13 of the 52 cards are a club. Okay, now this is where the overlapping part comes in. We're going to minus the overlap. What is the overlap? A king of clubs. How many cards are a king of clubs? 1. 1 out of 52. So that's how we process an overlap. Okay? So we would have 52 as our denominator. 4 plus 13 is 17 minus 1 is 16. So 16 divided by 52. We'll say 30.8%. Questions for me? All right, number 3, find the probability that you chose a card with an even number or a heart. Union or intersection? Union, we have the word or. Okay, is it overlapping or non-overlapping? Can you have an even number heart? Right, so this is going to be overlapping, but we know it's still a union. All right, so what's the probability of an even number? So let's think about this. If we have one suit, we can have a 2, 4, 6, 8, or 10. Do we agree on that? So there's 5 per suit, 4 suits. How many are there? 20. Okay, how many are a part in the 52 deck? 13. Now, our overlap, okay? How many even numbers are a heart? How many hearts are an even number? 2, 4, 6, 8, 10. Correct? 5. Okay? So to subtract that overlap from our total. Let's see. 33 minus 5. 28 out of 52.
Yeah, that's right.
Almost half. A little over. 53.8%. All right, find the probability that you chose a heart or a spade. Okay, so it's or, okay, meaning it's the union. Okay, what's the I'm sorry, is there overlap? No, because heart spade can't do that. There's not one that's together. Okay, what's the probability of getting a heart? Plus the spade, which is also 13 out of 52. So that's 26 out of 52. And just think about it. You're basically you're taking half of the cards because it's half of the suits. So that's 50%. Okay, that's all we got time for. You're out of here in 2 minutes. I'll let you pack up. Okay, bring those back. We're going to finish your notes tomorrow.
No.
Are you the only one that got that?